Okay, so today we're going to work on 3.5, which is called divide and conquer. Our main goal for today is just dividing polynomials. So if you think about what we've done so far, we've added polynomials, we've subtracted polynomials, we just finished multiplying polynomials, and yes, that's right, we are now on dividing polynomials. So dividing polynomials is based on dividing numbers. I know, who'd have thunk, right? Okay, so it says write equivalent multiplication statements after dividing. Know when one polynomial is a factor of another polynomial. This word, there's a lot of verbiage here that I need you to remember. How is dividing polynomials like dividing whole numbers? We're going to use that today. How is factoring relating to division? Factoring. And how can a remainder of a polynomial division problem be used? Okay, remainders. Do you guys remember remainders? We haven't used remainders in a really long time. Remember when you first learned division and we were doing like, say, 5 divided by 2, you'd be like, 2 remainder 1. Remember that? So we're going to actually use the fact of remainders again to help us understand. Now, if you don't remember how to divide, not a big deal. We're going to remind you right now, and then it'll make a bunch of sense. So we've seen how numbers and polynomials relate in addition, subtraction, and multiplication. And now we're going to consider how to consider division. Division, you say? Like long division? Yep, that's exactly what we're talking about. And hold the judgment. It's actually pretty cool. So you haven't necessarily long divided. I don't know if that's how you say it. In a long time, because you guys have access to calculators. Now, our calculators are really great, but they don't necessarily know how to divide polynomials, right? Okay, so as usual, let's start by looking at how the operation works with numbers, because again, if it works in number land, where does it work? In algebra land, or in this case, polynomial land, right? Since division is the inverse operation of multiplication. I'm going to say that again. Since division is the inverse operation. Remember, inverse means to undo something, undo. So division undoes multiplication. The same models should be useful. The area model that we use for multiplication is also used with division. When we were using area models to factor a quadratic expression, we were actually dividing. Here, let's go. Oh, wait, what? Sorry. So the area model for x squared plus 7x plus 10 is shown. Use the model to write x squared plus 7x plus 10 in factored form. So if you remember, this is x squared, right? And then you have 7x is 1, 2, 3, 4, 5, 6, 7. And then there's 10. So then the way you'd factor it is you tell me how long this side is and how long this side is. Now, I usually put these guys down here, so it's a little backwards for me, but I still recognize that it's the same. So how long is this side right here? Anybody recognize? How long is this side right here? Someone said, oh, it's x. You guys all see x plus 2. See my x plus 2? Yes. And then over here, what would that be? If this is x plus 2, what is this side here? What would this side be? It'd be x. Very good. How many? Plus 5. Very good. It is plus 5. Ms. Johnson, what? 1, 2, 3, 4, 5. 5. Good. Okay. No worries. We're remembering. And for some of you who didn't use this, that's why it doesn't make sense to you. Don't worry. We will go over it in a second. Okay. So we also use number patterns to factor without drawing the area model. Use any strategy to factor the following quadratics. So I'm going to show you how I factor because I really like the way that I learned as an adult how to factor. I did not learn this as a student. I wish this was around when I was learning how to factor, because the method my teacher taught me was sit and think about it. I was like, okay, I'm sitting. It's not coming. All right. So the way I factor is I use the X and the box method. If you guys are familiar with that, I think some of you said you were. So the way I do this is I multiply the first and the last term, and that gets me 12x squared. And I get the middle term, which is 7x, and I put it down there. And then the question that I ask myself, which is really important, is what times what gives me 12x squared, and what plus what gives me 7x? This is a really important question. If you struggled at all with factoring, it's probably because this question didn't make sense to you. So I'm trying to make it make sense to you. So can you guys, so the very first thing that I do is I'd write out my factors of 12. So 12. So I get 1 times 12, I get 2 times 6, and I get 3 times 4. So which one of these pairs gives me a 7 when I add it? Which one of these pairs gives me a 7 when I add or subtract it? Yeah, exactly. It's 4 and 3. So I'm going to take my 4x and my 3x, and I'm going to write it over here. So 4x and 3x. And then I'm going to check just to make sure, especially with your negatives here, always check. 4x times 3x is 12x squared. Woohoo! 4x plus 3x is 7x. All right. So I'll link a factoring video from one of my other classes just so that you guys have access to it too. So then I draw my little box, and the first term, if this shows up, my first term will go in the first box and the last term goes in the last box, and these two will go in here. Okay, so let me just say that again. I put my first term in, x squared, here. I put my last term in, 12. And then these two terms here, I will write here and here. So let me highlight a little bit so you guys all see where everything is coming from, because that's always helpful to me. My notes for my own, when I was learning, were not this like neat. It was always like, what? And then when I go back to it, I'd be like, what? Okay. So trying to make it more obvious to you. So, okay, so then this is where they all come from. And then you ask, what's the greatest common factor here? So what's the greatest common factor between x and 4x? What's the greatest common factor of x squared and 4x? What do you see in both? What do you see in both? Yeah, it's an x. And then the rest of it is you playing missing. Play who's missing? So x times what gives me x squared? X times what gives me x squared? Very good. It's x. Very good. And then x times what gives me 4x? X times what gives me 4x? Very good. Plus 4. I just put a plus there because I want to remind myself that I'm adding. And then x times what gives me 3x? And everyone says, oh, plus 3. Very good. Okay, so we remember how to do this. Okay, and here's your two terms. Okay, so this is x plus 3, x plus 4. Okay, so I'm not going to go through every single one of these. I am going to link for you how to do what I just did so that you remember how to factor. Your job for today is to make sure that you can finish this one, and this one, however you factor. Okay, we will continue with this division part next week, but I really want to remind you how to factor because that's going to help you with this next part. Okay. All right, hope that made sense, right? Factoring here makes sense. Okay, I want to go back to this one little fact before we actually go. Okay, so this one, the focus says write equivalent multiplication statements after dividing. So I want to focus on this for just a quick second. So this was like fact families back in the day when you were in like 3rd and 4th grade, when you were learning multiplication and division. So remember when you did this, like you would go, oh, 5 times 4 equals 20. Do you guys remember fact families? Who else is in fact families besides 5 times 4 equals 20? Who's in his family? Do you guys remember this? This is like seriously 2nd and 3rd grade. Anybody remember this? So it's 4 times 5 equals 20. Do you guys all see what happened there? Another one in their family goes like this. 20 divided by what? What would I say? 20 divided by Yes, 5 equals to 4. And the last one in the family is 20 divided by 4. Good, equals 5. This is called a fact family. These are fact families because when you were first learning division, it was hard for your brain to process. I know you can't remember this at all, but your brain didn't understand 20 divided by 5 equals 4. So what people would do is they would say, well, do you know 4 times what would give you 20? Like, let's say the problem was 20 divided by 4. And your brain's like, I don't know. So then your teacher or something would be like, okay, well, do you know 4 times what would give you 20? And they're like, oh yeah, it's 5. And then they would say, okay, well then if you know that 4 times 5 is 20, we know that 20 divided by 4 is 5. So this is where we're going to start our next video. And so hopefully that makes sense, because remember, math should make sense. All right.